La 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 la. Yo, what's the deal? Ain't nothing, Paul. We just here laughing and all that.
Hello and welcome to the practice problems video for the substitution method. Okay, for this problem we're asked to evaluate the integral of, or find the integral of t to the third over 4 minus 2t to the fourth to the 11th power, dt. Okay, and they give us a hint saying that u is equal to 4 minus 2t to the fourth, okay? So first step is out of the way, they gave it to us, and now all we have to do is derive that. So we get negative 8t to the third, and then a dt because we implicitly derived, right? And now what I like to do is get dt by itself, or whatever is over here on the non-du side. So then we're going to divide by this negative 8t to the third, divide by negative 8t to the third, and then so those go away, so we get dt is equal to du over negative 8t to the third. Okay, so now that we have this relation as well as this one, we're going to plug as much as we can. We're going to replace all of these t's with u stuff. Okay, so t to the third on the top, we can't really do anything with that, right? But instead, so actually what I like to do first is rewrite this so that we have a negative exponent as opposed to something on the bottom. That's just a preference of mine. So that we don't have to deal with that fraction there. So anyways, now we're going to replace stuff. So this t to the third, we can't really do anything with that because we don't have any formulas over here that can replace it. So then, but we can replace this 4 minus 2t to the fourth with a u, so this will be u to the negative 11th power. And then dt, we can replace that with a du over negative 8t to the third. Okay? So now that we have that, we can continue on, and we'll actually see that the t to the thirds cancel conveniently, right? So we actually have this factor of negative 1 over 8, which we can bring to the front. So this is a negative 1 over 8. And then the integral of u to the negative 11 du. Okay, so we're at this line down here, and I'll continue this on the bottom. On the next slide. So we have negative 1 over 8, and then the integral of u to the negative 11 du. So we're just going to use the power rule for integration. So that constant will just stay in front, and then we're going to add 1 to the power. So that means we get a negative 10 instead of a negative 11. And then we have to take the reciprocal of that. So 1 over negative 10, right? And then we have our plus c comes from the integration, right? Our indefinite integral here. So we're almost there. But now we need to simplify a little bit. So these negatives in front cancel to become positive. So we have a positive 1 over 80. And then u to the negative 10 plus c. And just a reminder, our u in the beginning was 4 minus 2t to the fourth, and now is the time to replace our u with the t stuff. So this is going to be 1 over 80, not an 18 like I just drew, 1 over 80, and then times 4 minus 2t to the fourth to the negative 10 power, and then plus a c. Okay, so another way to write that, this is our answer technically. You could also say 1 over 80 times 4 minus 2t to the fourth to the 10 power, and then plus a c if you'd like, whichever way you would like to do that, and that's just a stylistic choice at this point. And what I always like to do is I'll take this equation down here, and what I like to do is check my answer, because maybe I'm just a little bit paranoid, but you know, or I could say just careful. So anyways, so let's take our answer, right? So we're going to take that, so minus 2t to the fourth, and then our minus 10 plus c. So what we're going to do is differentiate this with respect to t. Okay, so we'll derive that once. So the c is going to go away for sure. We have our constant in front. Our power is going to come down and be a negative 10. Then we have everything inside stays the same, except for this power decreases by 1, so it goes to negative 11 instead. And then due to the chain rule, we have the derivative of the inside, so that's going to be a negative 8t to the third power. Okay? So let's see what goes on here. So we have a negative 10 times a negative 8 on the top, so that's a positive 80. So positive 80 over positive 80, that's going to turn out to be 1. Then we have 4 minus 2t to the fourth to the negative 11, and then we have this t to the third there. Okay, so this is going to turn out to be a 1, and then we get that this is equal to t to the third over 4 minus 2t to the fourth quantity to the 11th power. Alright, and this was actually in our integrand to start with, so we are good. We have just checked our answer.